Hello, everyone. I hope you can hear me well. My name is Sanja Lukac, and I'm sales engineer at Exoreti. I would like to welcome you all at today's workshop, Electrical Design with VSCAD Cabinet Engineering. Thank you for joining us. The main goal of today's workshop is for you to get familiar with Cabinet Engineering module. This workshop is being recorded, and you will get the recording afterwards as well. At the end of the workshop, the survey will appear in your browser regarding your impression of this workshop. We would really appreciate your feedback, and so please, if you could, fill it out. Today with me will be my colleague Gaspar Konevšek, a technical consultant. Gaspar, yay. That will be joining us later to show you how to use Cabinet Engineering module. He will give you knowledge for better understanding of this discipline. Let's see what we will cover on today's workshop. First off, we will start with our company profile and who we are as Exoreti. Then we will go over fact about VSCAD and functional overview for VSCAD Electrics. After that, Gaspar will show Cabinet Engineering, and finally we have Q&A. We are Exoreti, and we offer innovative software and hardware solutions. We have many partners, and VSCAD is one of them. We offer service for individual solutions to your needs, provide consulting service and technical support. We are present in 8 countries, from Slovenia to North Macedonia. With 15 employees, we have 3 offices in Slovenia, Croatia, and Serbia. First, I would like to say a little about VSCAD in general. VSCAD is a company, also software, that exists more than 30 years. Started a small company and later became a part of Bull Group, and they have over 700 employees. It is present in 26 countries. It has about 35,000 users. Regarding the industries, our focus is on the machine building, building automation, and electrical installation. Then we will continue with project overview. This solution is made out of the 3 components. The first one is the software VSCAD Electrics. Electrics is last version. Second part is VSCAD Universe, and last we have AR application. This is a modular and scalable software useful for planning, designing, and development of electrical machines, planets, and buildings. It is present in 6 disciplines: electrical engineering, cabinet engineering, fluid engineering, P&ID, building automation, and electrical installation. As aspect today, we will be focused on cabinet engineering discipline. The electrical engineering discipline enables engineers and designers to plan, develop, and document medium and low voltage systems. We have symbols as per IEC standard, and we use this discipline for IT and telecom systems. The cabinet engineering. In this diagram, we have whole process. First, create schemes, design cabinets layouts. After that, 3D view and collision checks, route connections automatically, calculate wire lengths, check cable ducts, print labels and QR codes, label cores, and in the end we use QR codes for maintenance. VSCAD has different interfaces for softwares and for machines. Fluid engineering useful for pneumatic and hydraulic designing. Completely documentation using field device, material list, tube list, symbol library according standard. VSCAD Universe is database. Database has more than 1.4 million components from 360 manufacturers. Available formats are VSCAD, EDZ, DXF. Annual growth for users is 40%, for manufacturers 35%, awarded as best ECAD article database. Next are two success stories from our customers. There we have Wickman Group and Vago. Wickman used two modules, electrical engineering and cabinet engineering. Vago used all modules. VSCAD is modular, and we can only use the modules you need. I would like to mention a few more customers who successfully deployed a VSCAD in the everyday work. We have here ABB, AMD, Vago, Siemens, Philips, and many others. Now, my colleague Gasper will show cabinet engineering. Gasper, the word is yours.
Thank you, Sanja. First of all, I would say hello to everybody from my side too. If we go here, and here you can see the project, which is already finished in electrical engineering. And you can see here we have a lot of symbols. There are all parts included in this project. So if we create some new project in some new page in cabinet engineering, and we rename this first page, later on we will insert all these parts in our cabinet. So here in our first page, we will insert cabinet, door, and mounting panel. Now the question is automatically that this automatically is scaled, as you can see here. So we can turn on this 3D model view, and now we can just start. On the left side, we will insert our parts, and on the right side in the 2D model, we will let's say now we inserted this cable duct, and you can see we don't need to be careful how to place this cable duct. If we insert some other cable duct on the right side of our mounting panel, and on the left, you can see right now again, we don't need to be careful how to place these cable ducts. So we can also resize this cable duct. Let's say on the top of the mounting panel, we want 100 millimeters space. We can do this. And on the right side, we can resize this cable duct to the same length as cable duct on the right, on the left, like this. And then we can insert some more 80-40 cable duct, and we can use this. Let's say here we have to select these two items, and we can use these alignment objects here, and they are very useful, as you can see that everything is placed. And now we will duplicate these other cable ducts because we need 7 of them here, like this. And then you can see here we can also make some specific space between these cable ducts. Let's say vertical distance would be 200 millimeters, and then other distance here we can also place, it's like 145 millimeters. On the left side, you can see our 3D model of our cabinet. We can refresh it. You can see all the cable ducts are here. And then this space is 460 millimeters. It's a larger space between these cable ducts because later on here we will insert the drives from Synamics. and here 200 millimeters. And for now, this is it. So we can insert some measures also here that we exactly know what are the measures. We will just insert some of them to see how to work with that. Let's say here, as before, it's 100 millimeters and 145. And what we have to do is also we have to insert some DIN rails from Phoenix, as you can see. And here you can see we don't need to be careful how to place these DIN rails, because we have these alignment objects, and we can actually place these DIN rails exactly in the middle of these two cable ducts. You can see later. So one more. And now all what we need to do is to mark 3 of them, 3 cable ducts, and click adjust vertical distance. This. So we have to mark 3 objects, and this DIN rail jumped into the middle. We will do with this DIN rail the same, and maybe we can resize this DIN rail. And if we click a tab button, here you can see we can insert exact dimension which we want, like this. And now everything is set. If we open Material Explorer, as I told before, we will insert all these parts from our project, which we finished before, into our mounting panel. Now let's insert some terminals. So as you can see, we can choose all of them together and place in the whole DIN rail. So we can look this 3D model on the left, and then we have to insert some more terminals. And here you can see that these terminals are multi-level terminals. And here are some power converters. So we will choose all of them together, this, and place it on the mounting panel. It's good that we can see the 3D view at the same time. And now we can also insert these contactors on the next DIN rail, this. And there are some terminals left. These are 24 volt distribution terminals. So we can zoom it and check everything is all right. And here is the place for our drive. So here you can see that we can mark all these components in some order, and in the same order will be placed here on our mounting panel. And now you can see we placed just Synamics drives, Synamics drive 120. And now we can go forward. We can just choose all of these fuses and place it, all of them together in this new DIN rail. If we go forward, there are some sockets left, from our project. And what else? We have some terminals. And these connector terminals. We will also place them all together. And now we have to place one more some more parts. We have to place the 24-volt supply from CTOP from Siemens. We have two 24-volt supplies, as you can see. So we will insert first one and then second one. This go forward. The second one is T13. So in the end, we will insert PLC, so CPU 1200 from Siemens, digital inputs, outputs, and safety model relay, all together like this. So actually now everything is finished. We placed all parts from our project in electrical engineering in our mounting panel. So we have all parts which we need, but now on the door you can see we still have some place. So we will insert some HMI like this. We can check it, but you can see that it's not in the right position. If we check these cable ducts, and we can place it on the right position to write the proper dimensions. So Y coordinate is -490, and that's it. Now this HMI is on the right position on the door. So before you saw some cable ducts here. These are virtual cable ducts. Actually, they are placed on the opposite side of the door. And we can place these virtual cable ducts, but what we have to do, what we have to be careful, that we also insert this virtual path. This virtual path, you can see it's a dot line, blue dot line, and it's because of routing. We have to place it that when we will do right now the routing. So now we have all elements. We will do this routing, and now, yes, now the software will calculate all the length of the wires in a cabinet. You can see right now. Now we have all information about the wires from what we need, the length. So here we can just insert the mounting panel into cabinet. And yes, as I told before, these cable ducts are on the opposite side of the door. So now you can see that visibility of our reference names are bad. So we can fix that. We can fix that. If we insert the intelligent selection reference name, we can move this reference name to upper place here. We can move it. We can move them, and the visibility of the reference names are better. But still, if we want still better visibility, we can actually turn on the background for reference cabinet name. So if you go to the settings of cabinet, you can see here we have a lot of options. We can change the font, maybe of reference name. Here we can change offset length. of wires, and here we have maximum filling degree of cable ducts. We can change to 10%. Why I did that? I did that because I want to show you that we have possibility if the cable ducts is full. In our case, these cable ducts which are colored red, they are more than 100% full. So that's also, we can now insert this side door, side wall, and check it again in this our 3D model. And we have also the collision check. So if we close this door, the collision will warn us if something is if the part is not placed right. So if here will be collision, this part which will be in collision will colored red. So we can check it like this. We can check this again, this our 3D model, but we can see that everything is fine in our case. So we can save this our 3D model to mesh with material, STL file, and so on. And then we can open this 3D model in different softwares. So here we have interfaces for production, CAD cable, comacs, and so on. We have also ProClima from Schneider Electric. This is for calculation of the heating. So now we can do what we can do. We can generate this wiring chart. And here in this wiring chart, we will get all needed information from our wires. So here we have a potential name, symbol pin from 2, wire color, cross section, and wire length for each wires in our cabinet. So now we can also make these QR codes, and we can generate these QR codes from our project. And what is this good for? We can stick these QR codes on the parts of cabinet, and with a cabinet AR application, you can check this cabinet AR application on the right. Here you can see on the Synamics drive, we have these labels, and we can scan it with mobile phone, and we can check the wiring. We can check which wires are wired, which elements are wired, and then we can send this document to our colleagues, and everybody knows which wires are connected in the new cabinet. Then you can see we have also the 3D model. We can check the 3D model from this our Synamics. And you can see here, if we scan again, we have a power supply. Now we know the part number, and that's not all. We can go directly to vendors page and check all data from this part in our cabinet, and then we can also jump directly in our project, and we know now where this drive is, and we can even write a note and upload it to our colleagues. So yeah, for now this is it, and maybe we can go back to you, Sanja.
Now we can start with Q&A session. First question for you is how we can use the interface ProClima from Schneider.
Yes, this interface ProClima, what we have to do is to insert the proper information in configurator, like dimension of the cabinet, then material and power dissipation. Power dissipation are also in part information in parts. So if we have this information in our parts, then automatically all parts which are in our cabinet summarized this power dissipation, and then we have a complete this power heat. And when we have all this information, the ProClim automatically calculates the proper ventilation system for our cabinet, and then it automatically gives the proper ventilation for our cabinet from Schneider.
Okay. Just a moment. Do you have a course about cabinet engineering?
We don't have a specific course for a cabinet engineering, but in the basic training, there are some lectures. Actually, this training is a 3-day training. In the end, we have some lectures about the cabinet, but maybe if there will be more inquiry just for cabinet engineering, we can do, let's say, 1-day training just for cabinet.
Okay. Thank you, Gasper. We will answer other question after the workshop. And the last, on this slide, you can see our contact information. So please, if you have any question, feel free to contact us. Thank you for your time and enjoy the rest of your day. Bye.